Hello everyone, welcome to the session number 10 on Introduction to Statistics. So day 10, and we are discussing about the second step of statistics, organize the data, right? So in the session number 9 we completed the frequency distributions, right? Like how to represent the data in the form of continuous class intervals. Okay, so end of that session we arrived at one question, right? How to convert, because in the session number 8 we learned about discrete class intervals, right? Discrete class intervals, and in session number 9 we discussed about the continuous class intervals. Okay, so now our task is, suppose if you have discrete class intervals, how we can convert these discrete class intervals to continuous class intervals. Why? Because these continuous class intervals plays a very important role, because you will be learning in the next coming sessions that we generally use continuous class intervals to draw histograms. So this is another way of representation of data. Okay, and we also like these class intervals, continuous class intervals, there are many applications, right? So that we will discuss in the next coming sessions, but in this session our focus will be how to convert discrete class intervals to continuous class intervals. Okay, yeah. Okay, so this is about me. So this is my LinkedIn ID. You can follow on LinkedIn, and you can ask me anything, whatever you wanted to ask related to anything. Okay. Okay, so these are all the ways we can organize the data, and if anyone miss or if anyone wanted to learn with the basics, and especially how to represent the data in the form of pie charts, bar graphs, Pareto charts, and also tally marks, please go through my YouTube channel. So there you will find all the videos is related to these topics. Okay, so here in the session number 8 and 9 we are done with the discrete class intervals and continuous class intervals. Okay, so here our focus is this: how we can convert discrete class intervals to continuous class intervals. Okay, so it is a very simple. Okay, so there is no difficulty at all, it will be very easy. Okay, so let me show you with an example. Okay, how we can convert. First of all, how you will identify the given class intervals are discrete or continuous, right? So in the session number 8 I told, right, if the upper limit of the first class interval is not equal to the lower limit of the next, you just observe these. Okay, if these are all different, then they are said to be discrete class intervals, right? As I said, a discontinuity is there between one class interval to another class interval. So therefore the, so if we want to suppose, let's say a data point is there 7.5, where you will represent, where you will put, in which class interval you will put this data point, because here you have 1 to 7 and the next class interval is starting from 8 to 14, right? So then you cannot represent this, you cannot put this data point 7.5 in any class interval, right? So therefore there is a need of continuous class intervals, right? So not only these, as I said, we use continuous class intervals in varieties of applications like drawing histograms also. Okay, so let us, so it is a very simple method. We can like convert these discrete to continuous class interval. So in the first step is, as we know here, all the class intervals are discrete, right? So you consider any two consecutive class intervals, any two. Either you take first two or second next two or next two, you take any two consecutive class intervals. There is no issue. Okay, so that is the first step. So here I am taking 1 to 7 and 8 to 14. Clear? So now identify the gap. The second step is identify the gap, upper limit of the first class interval and lower limit of the second class interval. So what is the upper limit of the first class interval? That is 7. And what is the lower limit of the second class interval? That is 8, right? This is the upper limit and this is the lower limit, right? Now you identify the gap is nothing but the difference, right? So 8 minus 7 is equal to how much? 1. So that you identify in the second step. Then in the third step you just adjustment, we need to make a one adjustment. How we will find the adjustment? That adjustment is nothing but whatever the gap you found, right? 1, you just divide always with 2 only. Clear? So then you are getting 0.5. Clear? So then in the second step 4, what you need to do, you subtract this 0.5 from each lower limits, then add same 0.5 to each upper limit. Clear? So that these are all the four steps we should follow. Clear? So okay, let me repeat again what we need to do. First you just find, you take any two consecutive class intervals, then find the gap between the upper limit of the first class interval to the lower limit of the second class interval or next class interval. So you divide that gap. So generally what will happen whenever you have a discrete class interval, the gap between them is always 1. If you take even if you go to advanced statistics, so there you will find that the gap between them is 1 only. So therefore your adjustment will be always 0.5, as simple as that. So only thing you need to do is, even without even following these steps, you just, if a gap is 1, you just subtract that 0.5 from each lower limit and add 0.5 to upper limit of every class interval. Clear? Then accordingly, so the new class intervals will be, so I said subtract 0.5 from each lower limit. So therefore 1 minus 0.5, so that will be 0.52 and 7. So add 0.5 to each upper limit, right? So 7.5. And then next 8 minus 0.5, that will be 7.5 and 14.5. And then next 14.5 to 21.5. And then next 21.5 to 28.5. Then next 28.5 to 35.5. So the next 35.5 to 42.5. Now you can see if the data point is 7.5. So where it will come? It will come in the second class interval, right? Why? Because these are all the continuous class interval. Now these discrete, they became continuous. So in the continuous class intervals, I said, right, only the lower limits are included. Only the lower limits are inclusive. Am I clear? So this is very important, right? Whereas in the discrete class interval, both lower limit and upper limit are inclusive. Clear? So here if I want to put this data point 7.5, so that will come under this class interval. Okay, even though here it is there, but it will come under the second. Why? Because 7.5 is in the lower limit. Clear? So this is the way we can convert discrete class intervals to continuous class interval. Clear? Yeah, so that's all for this session. Okay, thank you so much. We'll meet in the next session.